Hey everybody, it's Mrs. C, and I know you're all starting to find your way into the world of graphing quadratics, and I thought I had an intuition video on graphing quadratics, and to my shock and dismay, I don't. And so I looked on YouTube. I didn't see anything I was like crazy about. So I thought, all right, let's just do that. Let's do this. And so here we go. Graphing quadratics 10101. Yeah, baby. All right. So what's the big deal? Well, there really isn't a big deal. When you graph a parabola, it's not a perfect science, which is one reason is why you do not see lines on this graph, because to graph a parabola, oh my gosh, I did not even use a drawing tool for that. Can you even believe it? I can't. It's a curve, first of all. So quadratics curve, and they curve like this. They can be going upwards, they can be going, let's do another one. They can be going downward. So many things going on with quadratics, and so when we graph them, it's not all about it's not about the accuracy. It's about identifying all of the different solutions that the quadratic has. So I just want to go over what are the qualities of a quadratic. So first of all, let me do a little bit of a different graph. I want to come here and do something like that. Okay, now the curve's not the greatest, and what I'm trying to say is that's not really the point. When you guys always say that when I say I'm giving you a test on quadratics, the first question, does accuracy count? Because I don't really do good accurate curves. Nobody does. Nobody does. What's important? All right, well, obviously, if you're graphing a quadratic, probably the most important thing is a solution to the quadratic. In this case, I'm showing you a solution that appears to be there and there. And depending on whether you're using the quadratic formula or factoring or just the graphing calculator, find these solutions, you might have different answers as far as forms. For example, you might have a decimal if you used a calculator. You might have radical form if you're using the quadratic formula. That's not what I'm talking about. Right now I'm talking about the fact that you have a curve and you know its solutions. So for me, I always want somebody to identify what the solutions are, being the x-intercepts, right? So the x-intercept in this case is a 2. I'm always okay with the x-intercept equals 2, but I know there's teachers out there that prefer it as an ordered pair. Then you would say 2, 0. Okay, then coming on over here to the left side of my curve, I see my other x-intercept. My other solution looks to be a little short of, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. For all intents and purposes, let's call it -9. So we have the other x-intercept is equal to a -9, or for those teachers out there that prefer the ordered pair, -9, 0. That's my other x-intercept. So what else do I have to identify? Well, I know for me, I'm not happy if you don't actually identify all the intercepts. So in that case, we're talking about the y-intercept. So I want somebody to explain to me that the y-intercept is, what is it? 1, 2, 3, 4, -4. And again, we could do 0, -4 is the ordered pair for that not a solution, right? The y-intercepts aren't the solutions, the x's are. And so for the y-intercept, we're at the -4. So what else could I possibly ask? I could ask you to tell me the vertex or the axis of symmetry. Those are two other ones that I like. And so looking at this, do you know what the vertex of the curve would be? Absolutely. The vertex of the curve, it was so smart of you to come up with that, is your minimum point. I'm going to come from here because I have more space at the top. The minimum point, the point at which the graph can get no lower. It is the minimum when it's actually opening up. It would be the maximum if it was curving and it was going downward. So in this case, let's call that point my vertex. Now there are ways to calculate the vertex. If you use a graphing calculator, you're calculating the minimum. If you're using the quadratic formula, you're using x is equal to negative b over 2a. Negative b over 2a is the vertex formula. It's the part of the quadratic formula that actually calculates the vertex. And so if you didn't have a graphing calculator, you would use x equals negative b over 2a with your quadratic that I never gave you. And you would find out the x value of your vertex, and then you'd go ahead and have to plug it in to find your y. That's another video. That's not what we're doing today. We're just talking about what if I already know the vertex. Well, say I know that the vertex is, I don't know, what does that appear to be? 1, 2, 3, let's call it 4, 5, 6, 7, 4, 7. So we'll call it, let's get our numbers right. We'll call it negative 4, negative 7. It's in quadrant 3, right? It's all negative, and we call it the vertex. It appears to be there, right? It appears to be like that. Okay, last thing that I really require is my axis of symmetry. I am a stickler. I always want the axis of symmetry not only identified, but I actually want it drawn on the graph. The axis of symmetry is the imaginary vertical line that cuts through the center of your graph. So let me just readjust here for one moment. I am going to rewrite my vertex down here, negative 4, negative 7, okay? I'm going to erase that so that I can do a proper axis of symmetry. I told you I am a stickler for that axis of symmetry. I want my students to see how important the axis of symmetry is, and I'll explain why. First of all, how do you identify the axis of symmetry? Well, number one, it's always your x value of your vertex. So it's a vertical line, so it's x equals negative 4. That's how we write the equation of a vertical line, x equals, and it's through negative 4. And so the axis of symmetry is at x equals negative 4. Why is the axis of symmetry so important? If you're drawing a curve, then you have to understand that because it's symmetrical, then points from here to here are equally spaced. And I can actually use that to see that that was kind of a crappy sketch because it looks as if it should have been a little bit closer that way. So the points, right, should be equally spaced, symmetrical to the axis. All points on the graph are symmetrical to the axis of symmetry. Makes total sense if you say it out loud. Okay, so those are the basics for me. Let's go to the next page because it's getting a little bit cluttered. All right, so one more time. What were the most important parts? Let's try it again. Do you know your parts? X-intercepts, otherwise known as the solutions. It's hard to make a dot on this program, sorry. There it is, okay. And y-intercept, and vertex, and axis of symmetry. Those are the parts when you're graphing that you always want to make sure that you identify. How you identify them is really up to you, in my opinion, because whether or not you have a calculator or you don't, that's going to affect how you go about solving it. So let's say I give you a quadratic, because really, let's start with a quadratic, right? We would have y equals, a nice little quadratic function, x squared. I'm doing the math in my head. Give me a second. Let's do positive 2x. And then I think in my head I did 8 plus 8. So how would you solve that quadratic? Hang on a second. You wouldn't do it in my... sorry about that. Minus 8. Okay. How would you solve that quadratic? I don't have a graphing calculator on me. So I would have to solve by trying to factor. And so let me just go ahead. You think of it, you have a checklist. You are looking for your x-intercepts, and there's usually 2. Your y-intercept, 1. Those of you who have been with me for a while know what this means. And let me just ask you, what does that mean? Excellent. It's time to wake up. It's time to wake up. And I'm already awake, so I'm going to keep on going. So I want to solve by factoring. I have no idea. What was I saying? Okay, sorry. I got thrown off. A checklist of things in your head that you want to do. You want to find x-intercepts, the solutions. You want to find the y-intercept. You want to find the vertex and the axis of symmetry. I call it the AOS. Once you find those, you're good to graph. So this is me, I always solve. It's the first thing I do. And so if I'm going to solve for y, I'm going to break this down into just factored form because it's easier for me because I don't have a calculator. So the factors of, I need it to add to be a 2, and I need it to multiply to be an 8. So multiplying to be an 8 would be a 4 and a 2 automatically. And then to be able to add to get a 2 or subtract, I'd want to make that a plus and that a minus. That would give me a sum of 2 and would actually give me a product of a negative 8. It's perfect. Anybody I just threw off there, you need to go back and do the video on solve by factoring if you don't understand what I just did. All right, so right now I have y is equal to the products of x plus 4, x minus 2. If I go ahead and set my products, my factors, excuse me, equal to 0, I would find that x, meaning set the y equal to 0, right? Because I'm trying to find the axis, trying to find the intercepts. Oh my gosh, I got thrown by the calculator, by my phone. Just shut up and do the work, Mrs. Say. There. I would set each factor equal to 0 and solve for x. And I think we can all see that that means that x would be equal to a negative 4, x would be equal to a positive 2. Those are my solutions, my x-intercepts. Negative 4 and 2. Check. Done. Okay, moving on. Well, now what do I move on to? Oh, that was the wrong thing to do. Sorry. Well, let's do y-intercept. That's easy. And a lot of you are like, I don't know. How do you find the y-intercept? Well, it's pretty easy because you're in standard form up here. When you're in standard form, y equals, and then you're descending, meaning your quadratic term, your linear term, and your constant term, and your x is positive, you're in standard form. Your constant is your y-intercept. So my y-intercept is at negative 8. I do not want to complicate things if they can be done easily. So negative 8 is the answer. Anybody asking themselves, how do I do that if I can't, what do I do? What if it's not? Well, I would put it in standard form so that I could. Your other option, instead of setting your y value at 0, you set your x value at 0, and you solve for your y. That's how you find axes, guys. You set the one equal to 0, and you solve for the other. All right, vertex. Do you remember the vertex formula I gave you? X equals a negative b over 2a. That's how you would find the vertex if you don't have a calculator to calculate the minimum. Then you might ask yourself, but how do I know what the b and a is? Have you solved quadratics before? If you haven't, maybe you need to do that before you do this. Your A, B, and C. Here's your A, here's your B, here's your C. And so, what is my B? My B is a 2. Let's get another color. I need another color. Color change. I'll just do black. B is 2, right? And A is 1. So I have x equal to a negative 2 over 2 times 1, which is 2. So my x value is, what is it? It's a negative 1. My x value is a negative 1 on my vertex. I still need my y value. How do you find a y value if you have an x value? Well, you plug it in and find out what you get. So if we come back here and we say, now I know my x value is a negative 1, and I actually have a function which is y equals x squared. What's negative 1 squared? It's a 1. Plus 2x, what's 2 times negative 1? Negative 2. And negative 8, what's negative 8? Negative 8. And then I put those together. My y would be equal to a 1 minus 2 minus 8. That would be a 1 minus 10. That would be a negative 9. My y value would be negative 9. Thank you. That's helpful. Negative 9. Hello, negative 9. Okay, last but not least, my axis of symmetry always being my vertex's x value in an equation of a vertical line, x equals negative 1. Those are all my players. Boom, drop the mic, ready to graph. Okay, ready to graph, but I got a lot of information all over my board. So let me move on to the next screen and we'll just go back and forth. So first things I want to do is I want to actually graph. Let's do a different color here. I want to graph my solutions, negative 4 and 2. Okay, so I've got a solution at negative 4, 1, 2, 3, 1, 2, 3, 4 right here, and negative 4, and I believe I had said a 2. Those are my x-intercepts. I'll put the numbers in later. I always want to make sure I did it right. That's why I sketched this thing out before I start labeling. I've got a y-intercept of a negative 8. Negative 8. 1, 2, 3, 4, 5, 6, 7, 8. Oh, Lord, I almost didn't make it. Woo! All right, go back. What else do I have to do? A vertex of a negative 1, negative 9. Vertex of a negative 1, negative 9. Goodness. Oh, wait, move over a little bit. Sorry. I'm trying to avoid the bottom of my screen desperately. Sorry. I know that's probably not very attractive, but I can't get down there. It won't do a dot. Not there. Okay, sorry. Usually would be a little bit bigger, but I'm having issues with my tool. Okay. And lastly, the AOS, which I already know, is my vertical line. So if I actually drew a vertical line right here, let's see if it'll let me do this. Come on, you let me do that. There we go. My vertical line looking like that, and then of course taking an eraser and making it a dotted imaginary line, right? Because that's what it's supposed to be. I'm cheating here. Okay, so my AOS shooting up through that value, hitting the Y over here. Now let's try to put these pieces of the puzzle together. I have all the information I need right now, and now I'm just trying to pick a color here so that I can actually do it. Do you see right here my y-intercept? I had said my y-intercept was at a negative 8. If my axis of symmetry is truly at negative 1, then I would automatically have another point on the other side, symmetric. That's the beauty of the axis of symmetry. It helps me not only plot points that I don't have, but it helps me check the ones that I do. In this case, it would help me throw in that extra point that I didn't have. But in this case, it helps me double check, did I do my solutions right? Because I should be equally spaced. There should be 1, 2, 3 spaces this way, 1, 2, 3 spaces this way. And there are. My solutions are symmetrical. And that is making me feel a whole lot better about the data that I found. Because that has to happen, guys. You can't be skew when you're doing this. And so let's get rid of all this extra stuff. Now, so sorry, I hit the snooze before. Now, I lost my vertex. I want to go ahead and put my vertex in, and I'm almost done, really. My vertex, use a different color for the vertex here. My vertex got a little bit thrown. My vertex was right there, and I always put a point when I don't have a program that's giving me a hard time. And then I would write vertex. Do you remember what it was? It was a negative 1, negative 9. That was the vertex. And I also had the x-intercepts. This x-intercept was it's at a looks like it's at a 2. Want to double check I did it right, even though I know I did. Yep, -4. And this was 2. And that's going to be at -4. So I've got those in. I want to write my axis of symmetry. AOS x equals -1. And I've got my vertex. I always count to see that I have 4 things. 1, 2, 3, 4. I've got my 4 things. That means I didn't forget to label something ordinarily. And now I just have to sketch the graph. This is the part that is maybe the most fun, but the least important to me, because it is exactly that. It's a sketch. And so when we sketch, right? It's not supposed to be crazy accurate. It's the best we can do. You can definitely do better in pencil on paper and not on a, not on an iPad. It's not the easiest thing to sketch. This isn't the iPad Pro. It's not easy to draw. And so that's your sketch, guys. That's your quadratic. That's how you do it. You identify the AOS, your x-intercepts, your vertex, and your, your y-intercept, -8. And, y-intercept, excuse me. I want to write that. The y-intercept at a -8. That's how you do it. Intuition on sketching a quadratic. Now, get out there and practice, because that's what it's all about. And you know where I'm going to find you. You know it. I'm going to see you on the flip side. Later.